Chinese rocket is on its way to the moon with a mission to bring back rock samples back down to Earth.
Prepare to have your mind blown. When China's Chang'e 5 mission drilled beneath the lunar surface and brought back new samples, what it found were earth-shattering. We will conduct deep study of these precious lunar samples, and it is for sure we will cooperate with global scientists and organizations on the scientific research. Water, once thought scarce on the moon, was found deeply embedded in tiny impact-formed glass beads spread across vast regions. Scientists remain astounded by these findings, which could revolutionize lunar exploration and offer groundbreaking solutions to our planet's ever-growing energy demands. On December 1, 2020, China made history with the launch of the Chang'e 5 spacecraft from the Wenchang Space Center in Hainan Province. This ambitious mission was set to become one of the most important lunar expeditions since the mid-1970s. Built to weigh nearly 8 tons, the probe's main task was to land on the moon, collect rock samples from beneath the surface, and safely return them to Earth. After a 23-day voyage through space, the Chang'e 5 lander separated from its orbiter and made a soft landing in a region called Oceanus Procellarum. This site, located near the moon's equator and on its far side, is an enormous plain that has attracted the interest of scientists because of its unique landscape. Close by stands the towering 5,250 feet Mons Rumker Formation, suggesting that the area once saw intense volcanic activity. The successful touchdown of Chang'e 5 was greeted with applause around the world. The last time lunar material was brought back to Earth was in 1976, making this mission a potential game-changer for space exploration. Within just 14 Earth days, the Chinese team drilled beneath the dusty surface and gathered samples thought to be about 1 billion years older than any returned by the Apollo program. When the ascent module soared back up to meet its orbiter, global viewers marveled at the thrilling spectacle of modern technology in action. By December 17, 2020, the samples were safely back on Earth after the return capsule landed in Mongolia. The entire endeavor was a point of national pride for China and a major milestone for space research worldwide. Scientists eagerly opened the lunar samples, hoping to learn more about the moon's history, including the processes that shaped its surface and interior. Many experts believe these fresh rock layers might challenge long-held ideas about the moon being dry and barren. The Chang'e 5 mission also showed the growing capability of China's space program. This launch succeeded in raising the country's standing among other spacefaring nations. With advanced drilling, sample return technologies, and a bold vision for future missions, China is poised to continue to expand our knowledge of the moon. For now, the triumphant landing of Chang'e 5 affirms that robotic ventures can still break new ground and create excitement worldwide decades after the first lunar explorers left their footprints in the dust. This historic success stands as a beacon of exploration, inspiring humanity onward. China's Chang'e 5 lander made history by touching down in a spot on the moon that few expected. This unique landing location, known as Oceanus Procellarum, stretches across the far side of the lunar equator. Despite its name suggesting a calm sea, this area is not an actual ocean but a vast flat plain made of dark volcanic rock. What makes it even more special is the towering 5,250 feet high Mons Rumker standing like a sentry near the landing zone. Scientists were excited because Oceanus Procellarum had never been explored up close by any previous mission, so the chance to investigate it was enormous. Before the lander arrived, scientists could only study this region from faraway spacecraft photos or orbiters. Those images showed signs of volcanic activity, large lava flows, and interesting rock layers waiting to be sampled. By choosing Oceanus Procellarum, the Chang'e 5 team hoped to discover valuable information about the moon's geological evolution. Extra intrigue was added by the presence of Mons Rumker, which is believed to have been shaped by ancient volcanic eruptions. Such formations might hold clues about how the moon cooled and developed, as well as possibly hiding rich mineral deposits beneath their surface. Another reason this spot surprised many people is its location on the far side of the moon. Most past missions focused on sites visible from Earth. Landing on the far side demanded advanced technology for communication because signals could not simply beam straight home without using relay satellites. Despite these technical hurdles, the Chang'e 5 mission successfully landed in Oceanus Procellarum and began its historic work. The lander drilled deeper than any mission had in decades, searching for evidence of hidden water, volcanic layers, and intriguing crystals that might shed light on Earth's closest neighbor. Scientists consider this region extraordinary because of its unexplored territory and age. Much of the rock here is believed to be around 1 billion years older than the samples gathered during the Apollo missions. That means the mission could provide a fresh perspective on the Moon's origins. Experts hope that studying Oceanus Procellarum will help us understand significant events like meteorite impacts, volcanic periods, and the processes that formed the Moon's crust. All of these discoveries in such a remarkable part of the lunar surface have elevated China's space exploration efforts and energized the global scientific community, offering yet another reminder that the Moon still holds many secrets for us to uncover. Deep sample collection was the heart of China's Chang'e 5 mission, marking a breakthrough in lunar exploration. While earlier spaceflights gathered only surface dust and shallow rocks, Chang'e 5 drilled deeper than any mission had in decades. This was a bold step that promised to reveal hidden layers of the Moon believed to be far older and more varied than the material previously studied. Scientists wanted to see if these deep samples might confirm well-known theories or perhaps bring forth new ideas about how the Moon was formed. Soon after the mission's lander touched down in Oceanus Procellarum, a vast plain on the far side of the Moon, it began its much-anticipated drilling. Unlike past landers that focused on simply scooping up loose lunar soil, Chang'e 5's equipment reached layers that had likely never seen the light of day. These older deposits might carry clues to ancient volcanic activity, meteor impacts, and the cooling of the Moon over billions of years. By digging below the surface dust, the mission raised hopes that these undiscovered rocks could hold evidence of water, minerals, or other surprises few expected to find so far from Earth. Getting the samples was only half the battle. The lander had a small ascent module that took off from the lunar surface after drilling was complete. It rendezvoused with the orbiting spacecraft, transferring its precious cargo before heading home. This tight schedule, only about 14 Earth days, meant the Chang'e 5 team had to work fast and efficiently. The window for safe operations on the Moon is limited, especially when considering temperature swings and harsh radiation conditions. When the samples finally arrived back on Earth on December 17, 2020, researchers around the globe celebrated. The material came from deeper, older layers that could carry fresh details about the Moon's origin. For instance, many scientists believed that the Moon formed after a Mars-sized planet slammed into Earth over 4 billion years ago, throwing hot debris into orbit. If that story is correct, the deeper rocks could show remnants of intense heating or contain chemical signatures linking them to Earth. On the other hand, if they turned out to be different, it could spark an entirely new view of our nearest neighbor. Thanks to Chang'e 5's deep sample collection, the scientific community gained an invaluable chance to study material untouched by previous missions. This daring feat proved that drilling below the lunar surface is both possible and highly rewarding, opening the door for more ambitious projects and perhaps even for humans to one day unearth the Moon's deepest secrets themselves. Ancient lunar material collected by China's Chang'e 5 mission has amazed researchers around the world because it comes from layers believed to be about 1 billion years older than those gathered during the Apollo program. This fact alone makes them a rare treasure in the scientific community. By drilling deeper than many earlier missions, Chang'e 5 was able to reach material that stayed hidden from view for countless ages. This ancient lunar material tells a story of how the Moon formed and evolved over billions of years. One long-standing theory says the Moon was created when a planet about the size of Mars collided with Earth, throwing hot debris into orbit. As that debris cooled, the Moon took shape. However, many scientists thought most water and light elements would have evaporated because of the high temperatures involved. But the new samples challenged this belief. They suggest that the Moon still holds surprising amounts of water and minerals, some formed through repeated impacts with comets, asteroids, or meteorites that peppered its surface for billions of years. Scientists suspect that these impacts heated parts of the Moon's surface to extreme temperatures, melting rock and fusing it into small glass beads. Over time, water molecules from the solar wind or other sources became trapped inside. When Chang'e 5's lander drilled below the surface, it uncovered these glass beads and brought them back for study. Researchers quickly found that even though each bead holds only a tiny amount of water, their sheer number across the entire moon could add up to an impressive reservoir. Even more fascinating are the other crystals found within these ancient samples. One study points to a previously unknown phosphate mineral described as containing components that might help with nuclear fusion. While scientists are still unsure how this newfound mineral might benefit us, the possibilities spark both hope and excitement. Nuclear fusion promises far more energy than the nuclear fission we currently use, with very little radioactive waste left behind. Because these ancient lunar rocks are so old and carry traces of cosmic events, they reveal chapters of moon history that researchers are just beginning to read. They show signs of violent collisions, ancient volcanic activity, and even the presence of important resources like helium-3. Through continued research, this older, deeper material could help us understand how our nearest neighbor has changed over time, and perhaps even offer a clue as to how to solve energy problems here on Earth. The Chang'e 5 mission shocked scientists worldwide by revealing striking evidence of water on the moon hidden within tiny impact glass beads. Until recently, many experts believed that any water once present on the moon would have evaporated long ago, given its thin atmosphere and high temperatures during its formation. Yet when Chinese researchers investigated the samples brought back to Earth, they discovered a surprisingly high density of these microscopic glass beads, each containing small traces of water. These glass beads likely formed during the moon's turbulent past when meteorites, comets, and asteroids slammed into its surface at colossal speeds. The heat of these impacts melted lunar rock, creating teardrop-shaped, or spherical glass particles. Over billions of years, many such collisions peppered the lunar soil, steadily increasing the number of these glass particles. Though each bead measures less than a millimeter in size and contains only minute amounts of water, around 2,000 parts water per million, there are countless beads spread across the entire surface. On their own, each bead's water content seems negligible. But when considered as a collective reservoir, the impact glass beads could hold enormous amounts of water. According to estimates, if every bead on the moon contains the same ratio of water, then each metric ton of lunar soil could yield as much as 2,000 liters of liquid under Earth conditions. It means that future astronauts might not have to restrict their landings to the pole, where ice deposits are believed to exist in shaded craters. Instead, they could mine lunar soil almost anywhere, heat it, and harvest the water vapor released from inside these beads. Even more astonishing is the likely process that allowed water to form in the first place. Scientists suspect that charged hydrogen atoms blasted from the sun, known as the solar wind, combined with oxygen inside the lunar glass. Over countless impact events and centuries of bombardment by solar particles, the beads accumulated water within their structures. This revelation upends long-held beliefs about the moon's dryness, painting a new picture of a celestial body that may store lunar water in more places than we ever expected. Water on the moon was once thought to be limited and confined to the cold, shadowy craters near its poles. Then China's Chang'e 5 mission uncovered an astonishing finding. Tiny glass beads containing water are likely spread across the entire lunar surface. These beads formed during powerful meteorite and asteroid impacts that melted the moon's rock, creating microscopic glass particles. Over billions of years, countless collisions distributed these beads far and wide, marking a remarkable twist in our understanding of lunar water distribution. Each bead, just a fraction of a millimeter in size, holds a small amount of water, around 2,000 parts water per million. Although this quantity seems negligible within a single bead, the sheer number of beads found in the lunar soil points to a massive overall reservoir. Researchers estimate that each metric ton of lunar soil could produce about 2,000 liters of water if heated under Earth-like conditions. In other words, water may be accessible not only where ice deposits are locked in permanently shaded polar craters but also throughout the moon's equatorial regions. This fresh view changes how future missions might operate on the moon. Instead of landing only at the poles to seek small patches of ice, astronauts could consider equatorial or mid-latitude zones. By heating scooped-up lunar soil, they would be able to release water vapor from the glass beads. Once collected, this vapor could be turned into liquid water. In this way, pioneers living on the moon could potentially use locally sourced water for drinking, farming, and even for generating rocket fuel. The realization that water is scattered across a wide range of latitudes hints at more flexible lunar settlement plans and could lower mission costs by reducing the need to haul large amounts of water from Earth. Scientists have also pieced together how the water originally got there. Solar wind streams of charged hydrogen atoms from the Sun likely traveled through space until these hydrogen particles became trapped in the lunar glass, bonding with oxygen inside. Repeated impacts over billions of years helped bury the beads throughout the Moon's soil layer. This process shows that the Moon, although low in gravity and lacking a substantial atmosphere, can still hang on to vital resources in surprising ways. Thanks to the Chang'e 5 discovery, we now know that the Moon might contain far more widespread water than previously imagined, opening new doors for humans who wish to explore, live, and work on our nearest celestial neighbor. Quantifying the amount of water on the Moon has reached a whole new level thanks to data returned by China's Chang'e 5 mission. Traditional beliefs held that water on the Moon existed primarily in the form of ice at the poles, locked away in craters permanently shielded from sunlight. However, new findings paint a radically different picture. Chang'e 5 brought back samples that revealed tiny glass beads formed by countless meteor impacts over billions of years, each one containing minute traces of water. When taken together, these minuscule beads add up to an astonishing reservoir of lunar water. One of the most eye-opening estimates indicates that there could be the equivalent of 2,000 kilograms, roughly 2,000 L, of water in every metric ton of lunar soil once heated under Earth-like conditions to release the water inside the glass. While each bead itself is barely a millimeter in size and holds only a tiny fraction of water, their widespread distribution across the Moon makes their collective contribution to water stores enormous. Researchers even calculate that the total amount of water bound in impact glass could be around 298.7 billion short tons, an incredible number given how dry the Moon was once thought to be. Another important realization is that these beads are not confined to a single region. Due to about 4 billion years of collisions by comets, asteroids, and meteorites, the surface of the Moon has been steadily enriched with these water-bearing particles. This distribution means future lunar missions may have more flexibility when choosing a landing site, as water is not strictly limited to the poles. Instead, astronauts could dig in equatorial or mid-latitude locations, heat the soil, and extract enough water to support human activities such as drinking, growing crops, or even producing fuel. These discoveries fundamentally shift our perception of the Moon's resource potential. While setting up outposts at the poles once seemed the only option for tapping into usable ice, this new data suggests that humans may be able to build self-sustaining bases in other parts of the lunar surface. Although the Moon's sparse atmosphere will prevent lakes or rivers from forming anytime soon, the ability to gather and store water from lunar soil could support frequent missions and longer stays. In essence, quantifying the lunar water wealth has opened a fresh chapter in space exploration, one that moves beyond curiosity toward genuine resource utilization, offering real benefits for future science and even Earthbound energy needs. China's Chang'e 5 mission did more than just bring back lunar soil and rock samples. It also delivered one of the most surprising discoveries in lunar mineralogy. Among the materials gathered from deep layers of the Moon, researchers identified an entirely new phosphate mineral now christened Chang'e Site Y, in tribute to both the mission and the mythical Chinese moon goddess Chang'e. This breakthrough has astonished scientists everywhere, as early studies suggest the mineral could hold clues that may help solve one of humanity's greatest challenges, achieving efficient nuclear fusion. Traditionally, nuclear energy comes from splitting heavy atoms, creating radioactive waste in the process. But nuclear fusion, which fuses light atoms to form heavier ones, offers a cleaner, vastly more powerful alternative. While scientists have pursued fusion for decades, the immense amount of energy required to initiate and sustain the process has prevented us from mastering it. Strikingly, the newly revealed mineral from the Chang'e 5 samples contains a key component believed to promote the fusion reaction. Many experts have long theorized that helium-3, a rare isotope on Earth, could be harvested from the Moon to potentially fuel future fusion reactors. Before now, though, the big question was whether the Moon truly had abundant helium-3 locked in its crust. Chang'e Site Y has sparked a fresh wave of excitement because its structure hints at a natural capacity for housing helium-3. In fact, some scientists believe extracting helium-3 and other important elements from the moon could create a nearly unlimited source of clean energy back on Earth. This discovery has also led to speculation that nations and private companies may soon compete to mine the moon's resources. If researchers confirm that Chang'e Site Y and related minerals can simplify the path to commercial fusion power, the result could be a gold rush for lunar resources. Space agencies worldwide, especially those with existing lunar programs, are likely to step up their efforts to explore and exploit the desolate yet resource-rich environments of the moon. For now, the excitement is as much about deepening our understanding of the moon's geology and history as it is about rewriting the fate of Earth's energy supply. The ancient layers from which this rare mineral was extracted have survived billions of years of impacts and harsh conditions, preserving chemical secrets in the process. Chang'e Site Y, the brand new phosphate mineral, stands as evidence that the moon still has the power to surprise us and maybe even help ensure a cleaner, more sustainable future. China's Chang'e 5 mission has opened a thrilling new chapter in the search for clean energy. Among the mission's most surprising results was the discovery of a new phosphate mineral called Chang'e Site Y that contains elements believed to play a key role in nuclear fusion. Nuclear fusion holds the promise of generating far more energy than current fission methods while producing vastly lower levels of radioactive waste. This alone gives hope that one day a stable fusion reactor could supply clean, virtually limitless electricity on Earth. Equally exciting is the possibility of harvesting helium-3 from the moon. Helium-3 is an isotope many scientists see as an ideal fusion fuel. According to the findings sparked by Chang'e 5, the moon may hold sizable quantities of helium-3 within its dusty layers. Some experts suggest that just 27.6 short tons of helium-3 might power the entire United States for a year. That is an astonishing figure, especially when you consider the challenge humanity faces in moving beyond fossil fuels. Pulling valuable fuels from the moon may sound like science fiction, yet each new study and mission brings it closer to reality. If future lunar missions confirm that helium-3 is abundant and economical to extract, many nations and companies may race to build bases on the lunar surface, jumping at the chance to solve Earth's energy problem. At the same time, the moon's new image as a potentially rich resource is drawing both excitement and caution from researchers. Large-scale resource extraction would require an infrastructure for mining, transportation, and processing, something that might be decades, if not generations, away. Still, the evidence brought back by Chang'e 5 shows the moon holds more than just dust and rocks. It also carries the possibility of major breakthroughs in how we power our homes and industries. Water frozen in glass beads can support long-term stays, while newly found minerals and helium-3 deposits could solve the puzzle of practical clean fusion power. Such clean energy possibilities reshape the way we think about extraterrestrial exploration. Instead of simply planting flags, future missions could pave the way for giant leaps in science and technology that directly benefit life here on Earth. Thanks to Chang'e 5, the prospect of powering our grids with lunar-sourced fusion fuels no longer seems impossible. If we continue unraveling the moon's secrets, we may discover that our closest celestial neighbor is the key to a cleaner, brighter future for everyone. The Chang'e 5 mission's findings have opened the door to incredible opportunities for future lunar exploration and a booming space economy. With the discovery of abundant water in the moon's regolith, astronauts may no longer need to aim only for the polar regions to tap into precious ice deposits. Instead, missions could land just about anywhere, scoop up soil packed with tiny impact glass beads, and heat them to release water. This greatly expands the possibilities for building lunar outposts and habitats, since water is essential for drinking, farming, and producing rocket fuel. Furthermore, Chang'e 5's detection of a brand new lunar crystal with potential use in fusion technology has set off a wave of excitement among both scientists and energy companies. If this crystal proves effective in aiding nuclear fusion, especially with helium-3 as a fuel, humanity could gain access to a clean, high-yield energy source. Such a breakthrough would reduce our reliance on fossil fuels and might cut down greenhouse gas emissions. Naturally, that possibility draws the interest of major industries and governments worldwide. Companies see the moon not just as a place of scientific intrigue, but also as a resource-rich frontier ripe for exploration and possibly profitable mining. As a result, the global space community is racing to expand missions and develop better technology. China plans the Chang'e 6 mission to return yet more samples from the moon's far side, while NASA's Artemis program is picking up speed, aiming to put humans back on the lunar surface. Other nations and private companies are also stepping forward. They hope to build infrastructures like transportation systems, robotic mining equipment, and fuel depots that would kickstart a lunar gold rush. The promise of extracting helium-3, water, and rare minerals is alluring enough to prompt private investors to pour significant funds into space ventures.